Hey, we are in Unit 4 now, and here in Unit 4, we're going to be talking about polynomials. And so you may have already done a lesson about adding and subtracting monomials and polynomials, basically just combining like terms, keeping in mind that like terms have to have the same variable and the same exponent. Both, all right? And so there's some examples at the right. And then this sheet that you're looking at now is in your notes. All these that I'm going to use are in your notes. And this, you may want to just tear this page out and keep it beside you because it has all of the rules on it and an example of the rule on the right. So we may not do the rules in exactly this order, but this should prove to be very helpful for you. And that is on page 26A, the way it was numbered in term 2, which will probably change, but should be pretty easy to find. May also be the first page of a stapled pack that says Unit 4, or it may be stapled along with the systems unit. Keep turning. So first thing we're going to talk about is exponents. And when we talked about order of operations, I believe we did talk about exponents somewhat because that's our please excuse our, so that's part of our order of operations. And so let's just look at a number that we could do pretty easily. 2 to the first power is 2. If we don't see an exponent, we understand it's a 1. 2 to the second power, that's 2 times 2. That's 4, of course. 2 to the third power, 2 times 2 times 2 again. So that's 8. Now let's come back down that ladder. So if I were going down this ladder to go from the 8 to the 4, instead of multiplying, I would be dividing by 2, right? And then 4 divided by 2 is 2. So then 2 divided by 2 is 1. It's not 0. Things to the 0 power are always equal to 1. And that's why, because I need to be able to continue the same pattern. So again, that would also be divide by 2, divide by 2. Well, 1 divided by 2 is 1/2. Negative exponents are reciprocals. So here it is kind of in our rule. And that's an n, just meaning some number. So when it was 2 to the negative first, that's 1 over 2, because 2's 2 to the first. 2 to the negative second, 1 over 4. 2 to the negative third, 1 over 8. So when you're using a calculator to do these, I do not want decimals, especially decimals that aren't even exact because they don't end. And so what you want to do if you need a calculator, like if you don't know the number to that power, instead of putting it to the negative power, when you see negative exponent, you're going to do 1 over and make a fraction, and then use your exponent function to find out what's in the denominator. So here are some problems we're going to look through, and if you look, you might think some of these are exactly the same, but they do have some subtle and meaningful differences. So 2 to the negative fourth would just be one step further down than what we just did. So I know it's a negative exponent, so it's going to be 1 over, and then 2 to the fourth would be 16. Now, negative numbers doesn't mean the same thing as a negative exponent. And when you have negative numbers, Keep in mind, this -2 with parentheses around it means the -2 is raised to the 4th. So that means there are 4 -2's written out to be multiplied. Since there are an even number of negative signs, the negatives are going to end up canceling out. Watch what happens. This becomes +4, but then when I put these two together, I get -8 because they're different. But then when I put these two together, they're the same again, so it's +16 because they're both same signs. So rather than write that out, that would get time consuming, especially if it's a bigger exponent. Rather than write all that out, if you can remember this rule that a negative number, if it's to an even power, it's going to be positive. Okay? And if it's to an odd power, it's going to be negative. Because there's going to be one guy who doesn't pair up with someone. So this was +16. Now, there is a difference between that problem and the problem next to it. Those parentheses meant we're taking -2 to the 4th power. Order of operations says exponents come before multiplication, and really kind of that negative sign is like a -1 times 2. So this number 3 actually means take 2 to the 4th power, and then after you're done with that, make it negative. So if there's just one negative out to the side like that, that's happening at the end. So when you put it in a calculator, there are various ways to enter things in a calculator, and I think on another page I actually indicate some of those ways. But when you put it in the calculator, most calculators, if you want it to do what it does, or the way it's written in number 2, you have to use parentheses. Or your calculator is going to tell you it's -16 if you don't use parentheses. And then number 4 is kind of a combination of the two things. I see a negative exponent. I know I'm going to have a fraction. And there's a negative out front, so I know the whole thing is going to be negative. And then my 2 to the 4th is 16. Yes, those can be a little tricky. All right. All right, so I'm going to jump down to the middle section. And here it's just some practice. So if you have a variable to a negative power, you never want to leave things with negative exponents, just letting you know that. So for instance, on number 15, we would just do 1 over a to the 3rd. How about if I write it this way? Maybe you can see it better. 1 over a to the 3rd. So I just remove the negative exponent by moving it to the denominator. If by chance, and I don't think we have an example like this here, but if by chance I had something like this to start with, and there was a variable with a negative exponent in the bottom, I think of it like he's not happy down there. He needs to move to the top because it means reciprocal, which means we flip it, remember, from perpendicular lines. So to make an exponent positive, it needs to basically switch sides of a fraction. If it doesn't look like it's a fraction, you're going to make it a fraction. Now, just because there's one negative exponent doesn't mean everything is negative. So let's take a look over here at number 20. So number 20, I see the d has a negative exponent. So the d is going to come to the denominator. I'm going to write it down here so it's a little easier to see. The c does not have a negative exponent. He's going to stay where he is. And that negative sign could be with the C or just out to the side. Number 17, anything to the 0 power. No matter how messy it was inside that parenthesis, if it was all being raised to the 0 power, it would just all be equal to 1. Now, again, doesn't apply to everything. You might have something like 3 x to the 0. Well, that's not in parentheses. So the x to the 0 power, it's only the x that's to the 0 power. So this would just be 3 because it's the same as 3 times 1. Or 3x to the negative 5th. The 3 is not in parentheses. That exponent only belongs to x. So 3 would stay up top. X would come to the bottom. His exponent would become positive. All right? So that is a little about your negative exponents and 0 exponents. Be a few things that are going to make even more sense, hopefully, after we go over the other rules. So if you can't type an exponent and you're trying to send me a message, if you use the caret, which is Shift and 6, that will let me know you're trying to type an exponent. On your calculator, the buttons might vary. You might see the caret button. You might see a button that says y to the x or x to the y. And you would use that button between the base and the exponent. There may also be a little box. Your phone calculator also has something like this if you turn it in landscape mode. So turn it sideways so it's longer horizontally. Then you should see that your phone calculator turns into a scientific calculator. I haven't seen anybody's who doesn't yet. So these I do not intend for you to work out by hand. I intend for you to grab a calculator and, for instance, do 9 to the 3rd power on number 4 there. 9 to the 3rd. Hit equal. And you should get 729. So things grow very fast when we're using exponents. That's why we talk about exponential growth. All right. So we get down here and we have two different things. We're going to learn here about the product rule. And you could look back on your other sheet, but I am going to tell you. The product rule means that when we're multiplying two of these monomials, just means it has one part, one term, we add the exponents if the bases are the same. So think about this. Why does it work? Well, let's see if there's one of these that doesn't have a bazillion. Let's think about what number 18 there actually means. What it means is that there are, right? If that says w to the 3rd, that means there are 3 w's written out to multiply. And we're going to multiply that times 5 more w's. I'm sorry, my little dots for multiplication in between aren't coming out very well today. How many w's are there altogether then? 8. Is there a way that we could get that without doing all this? Yes. We could just add the exponents. So pretty simple. If you can add, you can do it. So with this 10 to the 2nd times 10 to the 5th, even though that's a number, we're still just going to add those exponents for now. Don't try to multiply 10 times 10. That would be like doing extra for it, right? Number 20 is really just kind of stating the rule. So 10 to the a times 10 to the b, add the exponents. This would be 10 to the a plus b, because we don't know what a and b are. So that is the product rule applied to some variables, to some single bases. We can apply the product rule to other products. They're still monomials because they just have one term, but now you're going to see things that have coefficients and they may have multiple variables. So basically it's like a few little problems all in one. All right, it's like a few little problems all in one. And let's see here. There we go. So I'm going to work down this left-hand column. So you are still going to multiply the coefficients. The coefficients are not exponents, and they don't behave like exponents. So 2 times 4 is still 8. Not changing that. And then I write down my x, and then I have 2 plus 3 is 5. So I'm only adding the exponents that are on the same basis. And then y is still y to the second because we did not have any more y's to add to that. All right, next one, 7 times 12. I got 84. Q, 5 plus 3 is 8. R to the 5th. Sorry, my 8's not looking much like an 8. Now, what you're going to see is that the variables are going to be written in alphabetical order. So sometimes the second monomial is going to like sneak a letter in between. That's what's going to happen in 25. So 9 times 5 is 45. Then I have x. 10 plus 5 is 15. Then we're going to write the y next, because alphabetically it would come before z. And it's going to stay y to the 3rd because it's the only y involved. And then z is going to stay z to the 2nd. Now, if you were doing a paper for me and you left the y to the 3rd at the end, I would not mark that wrong. But proper form would be that we put them in alphabetical order. So 27 tosses in a couple decimals, still the same process, guys. So 1.3 times 0.5 is going to be 0.65. You could always grab a calculator for that. And then A, 6 plus 2 would be A to the 8th. Then the B, 11 plus, here's the tricky part. That B who doesn't have an exponent, it's understood that he has a 1. So that second one does bring another B to the product. So 11 plus 1 makes B to the 12th. And then C, 5 plus 3, C to the 8th. So down at the bottom one, number 29, we have lots of 1s on these. And it may help you just for every variable that doesn't have an exponent, you give it its own little 1. May not need to do that, but might help you to remember. So negative 2 times negative 2 times negative 2, I'm going to write this below so I have more space, makes negative 8. Then I'm going to go with my x's. So I have x, 2, and one more at the third monomial, so x to the 3rd. Then I'm going to look for y's. So I have y to the 2nd in the middle and one y at the end. So I have y to the 3rd. And then z's. And I see that each one has one z. So 1 plus 1 plus 1 also makes that z to the 3rd. That, my friends, is the product rule. Pretty easy once you get the hang of it. Okay, so just remembering the rules. You've got your sheet there to help you remember.